Hello, welcome to our presentation of optimizing the construction costs for the construction sector. And we start with the first slide. So this is a particular flowchart which we are using for the optimizing the construction costs. First of all, we look at the analysis of the cost for the construction projects, then divide projects into categories for cost overruns, understand the gross profit impact. Then we take three different branches. Look at the the cost drivers for key projects. Look at capital rationing issues, understand the variances, understand the forecasted cash flows. Then you understand the finance impact, cost impact, and negotiate with the key players. Understand the manpower and material and optimize the same. So for the first three steps, we recommend that the top management use apps, and the last steps that we recommend that the company uses the BI tool. So first of all, we divide the projects into the categories for cost overrun. So here it is a time overrun percentage, and here it is the percentage overall cost. So 1, 2, 3, 4, 5, all these 5 projects actually account for total 100%. So this has been divided. Now we are looking at percentage cost overrun based on the time overrun. So intuitively, this mark shows that as the cost to time overrun increases, your cost overrun percentage also should increase. But here we see the circle is smaller. So this is for the project T. So now we need to understand why is it so. But we also come to know that project A and project D are the critical ones in terms of the cost overrun thing. Then next, in the next graph, what we do is we look at the financing cost. That means one is this thing. So you look at the financing cost overrun percentage usage. So here you see that, okay, fine, between 15 and 30% for both of them. And we look at the time overrun. So basically find that for the projects which have got a higher value, your basically time overrun percentage actually adds more to the these higher cost projects are actually impacted more by the time overruns. This is what this graph is actually showing. Then we look at the gross profit impact. So here on the x-axis we have looked at the percentage gross profit, and here on the y-axis we have looked at this thing. So your graph is actually going upwards here. That means your percentage gross profit is reducing as the time overrun increases. And now here we see this particular graph for project E and then for project A. Now this project E graph actually has a higher percentage graph of it for a higher time overrun. So we believe that it should be coming towards this side. And our endeavor is that the impact should come downwards. So you basically should stretch down. That means have higher gross profit and have lower time overruns. And understand the key cost drivers for key projects. So what we have done is we have taken project T, project A, and project D, and we have looked at the percentage distribution. So if you look at this particular graph, you actually find that the contractor payments for project E are significantly lower than that of the project A and D. So we decided to investigate further. So within this, actually, this thing we found that we are looking at the percentage of total contract. So the percentage of the work complete for most of these contracts for project E was actually on the higher end. It was closer to 95%. This is the percentage pending payment. That means this is a huge payment which is actually pending for this particular contractor, Muhammad. And the percentage of the contract was very high. So this actually explains why that project was showing a better gross profit. We looked at the impact of the cost dependence of this particular contractor on the other projects. So you look at this, the project numbers A and project numbers D are actually being significantly impacted. And there's a huge dependence upon this particular project. Then we looked at, so that means that you need to clear Muhammad's payments for all these projects to be completed. But herein we come down to the problems of capital rationing. So what it actually means is capital rationing basically means that, look at this, that means this project number E is actually completed. So once you pay Muhammad, this will go up. That means this is a percentage over cost, so this will go up. This value has to go up. So that means it should go up. And for project D and for project A, they should actually come down. That means the percentage overall cost should come down, and the time overrun should also come down. And the cost overrun graph circle should also fall below. So then we look at the next is the time variance, the project variances. So we look at the variances in terms of the cost related, tight project schedule, the design changes, the changes by the client, unsuitable construction planners. So here look at the cost planners and we look at for this particular project, this is the base case cost, this is the minimum value, and this is the maximum value. So this will all come from history. And based on that, we had arrived at an average cost of 18,500. But once we plot it on the normal distribution curve, the most probable value comes out to be 18,963. That means that only an 18.05% chance that 18,500 base cost would be met. And there's a 95% chance that 19,928 would be met. Then we look at understand the forecasted cash flow. So again, you have this capital rationing. That's a problem. So we look at each of these projects. So this was the initial outline. This is the cost of delay, and we look at the forecasted cash flows, and then we look at the projects with the maximum NPVs. So, like for example, if we have say limited cash available, so we had 450. So we would probably look at project B and project D only based on the collections. The other way to look at it is that how much can you optimize and crash the activities to optimize the cost. So for example, you have a deadline for 21 days. You want to minimize this total cost. So you have these particular activities which are pending. So how much to crash by how much time depending upon these constraints so that this cost is minimized. So this is the A to A sample diagram. Then we look at the financial cost impact. So then we look at the percentage material being used and the percentage manpower. And here we see that the financial cost increase for project A is the maximum. And for project D and project A, it's actually for project E, it's the manpower, and for the project D, it's actually the material. So then you have to start negotiating with the place. So first of all is you have to remove your Excel spreadsheets because and put everything onto a standalone system so that all the data is easily available. So this is a typical ACWS and the BCWS graphs, and these are the typical S curves which are coming in. And you actually have to be able to slice and dice. So this here, it is actually the target date versus the actual. So what this is actually showing is that what are the actual number of milestones which have been achieved for the actual targets for this particular month. So for example, I had targeted 100, but I actually achieved 120. But out of those 120, only 80 were relevant. So this will actually show that. Then you have to capture the complete history. So you have to look at the target date delay analysis. So this is showing the total cumulative delays by the project. Then you drill down to the block, plot, floor, and unit number. Then you look at the reasons for delay. So you look at remarks, project name, and the block. Then you look at the remarks and the task details. So you look at cost delay, and then you look at remarks and drill down to the cost delay. Then you look at project in the month, and the milestone, and the total cumulative delay. So how much has been the shift in the target dates. So all this has to be actually available immediately. Then you look at the cost of delay in history. So you look at the interest cost per month, then the block, plot, remarks, and the milestone. More the facts, the better it is. Then you have the cost of delay alert. So this particular project for here, this is the alert. And this is the builder delay, cost delay, and management delay by milestone, interest cost by year. Then understand the manpower and the material impact. So you look at the average holding cost per block, plot, and the milestone. This is a total number of weeks of delays. This is the holding cost, and then this is the interest cost, and this is the actual cost by project, by block, by the flow. This is the average holding cost alert, and this is the average cost per the block. Similarly is the case with the manpower. You have employee, milestone, the labor, and this is the total cost, and this is the addition by employee and the type of delay. This is the case for the purchase optimization. You have a manufacturer, you have steel and RMC. So you're actually minimizing the total cost given these particular constraints. So that means that the total given is going to be less than equal to the required, and the total available should be greater than equal to the total which is given from each manufacturer. And that's it. So with this we end up, and thank you very much for your time.